So welcome to today's video, guys. We are going to be talking about using variation of parameters to solve ODEs of this form. We can use in the previous video we have used method of initial guess. That's initial guess method of undetermined coefficient. So to solve this kind of question using variation of parameters, the first thing, as I said, is to always solve the homogeneous part of any ODE that you see. To solve the homogeneous part of it, we have r squared minus 5r plus 6 equals to 0. R squared minus 5r plus 6 equals to 0. Which means our r, um, looking at this, okay, minus 3 minus 2 can satisfy this equation. We can have r minus 3, r minus 2 equals to 0. R squared minus 3r minus 2r plus 6, yes, can satisfy this. Which means r equals to 3 or r equals to 2. So our y equals to e raised to power 2x or e raised to power 3x. So basically y1 equals to c1 e raised to power 2x and y2 equals to c2 e raised to power 3x. This now the complementary solution is yc equals to the addition of both solutions, c1 e raised to power 2x plus c2 e raised to power 3x. So we have gotten the complementary solution of this first ODE. Let me write here. Y is equals to C1 e raised to power 2x plus C2 e raised to power 3x. This is the complementary solution for the first one. So the method of variation of parameters is says that for anything like this, we can use our YP to be K1 instead of writing C1. We write K1 e raised to power 2x plus K2 e raised to power 3x. But the only difference here is that in this our complementary solution, C1 and C2 are arbitrary constants. But in this our y particular, K1 and K2 are not arbitrary constants. They are also functions of x. So the second thing you're going to do is to impose this K1 prime e raised to power 2x plus K2 prime e raised to power 3x. Impose this equation equals to 0. We impose this condition. K1, we just differentiate this K1 then e raised to power 2x and differentiate this K2 e raised to power 2x. In essence, we are going to write K1 prime y1 plus K2 prime y2. Impose this condition. This is the second order ODE. So this is what we are going to be working with as time goes on. So the next thing we're going to do, once we have this yp equals to K1 e raised to power 2x plus K2 e raised to power 3x, we differentiate the particular solution. Differentiating this, we have K1 prime e raised to power 2x plus using product rule. Don't forget, this is a K1 and K2 are both constant, are both functions of x. So we have K1 prime e raised to power 2x plus 2K1 e raised to power 2x. Differentiating this, we have K2 prime e raised to power 3x plus 3K2 e raised to power 3x. Now don't forget, from this one that we have imposed, that will mean K1 prime e raised to power 2x plus this, both are equal to 0, which means our yk1 equals to 2K1 e raised to power 2x plus 3K2 e raised to power 3x equals to e raised to power 3x. Now we need our second derivative. Our second derivative is going to yield, differentiating this the second time, we are going to have 2K1 prime e raised to power 2x using product rule plus 2 will come down again, so we are going to have 4K1 e raised to power 2x plus differentiating this, you have 3K2 prime e raised to power 3x plus differentiating this, 3 will come down, 9K2 e raised to power 3x. So now we are going to fit in these two, this 1, 2, and 3. We are going to fit it into the equation that we already have, and we are going to have y double prime, this one. So I will not write it up. Let me write it again. 2K1 prime e raised to power 2x plus 4K1 e raised to power 2x plus 3K2 prime e raised to power 3x plus 9K2 e raised to power 3x. This is our y2, y double prime, minus 5y prime, minus 5 of this, which is something like minus 10 k1 e raised to power 2x minus 15 k2 e raised to power 3x plus 6 yp plus 6 of this plus 6 plus 6 k1 e raised to power 2x plus 6 k2 e raised to power 3x, and everything is equal to x squared. Everything equals x squared. So what do we do next? We compare every one that has k1. Okay, this 4k1 plus 6k1, that's 10, minus 10k1, which means it cancels out each other. 4 and this 6, they cancel out each other. The ones with k2, we have 9k2, 6k2, 15 minus 15, they also cancel out. Wow. So we are left with 2k1 prime e raised to power 2x plus 3k2 prime e raised to power 3x. That's what we are left with, equals to x squared. Equals to x squared. So we now have two conditions now. We have the first equation. We have two equations now, equation 1, and we have this as our equation 2. So we are going to solve both of them to find the value of our k1 and the value of our k2. Then we can easily find the particular solution of this ODE. So solving these two, the first one is the first condition we give ourselves, k1 prime e raised to power 2x plus k2 prime e raised to power 3x equals to 0. And the second one is 2k1 prime e raised to power 2x plus 3k2 prime e raised to power 3x equals to x squared. So we have to solve for k1 and k2. So what do we do? From the first equation, we can write k1 prime e raised to power 2x equals to minus k2 prime e raised to power 3x, which implies that k1 prime equals to what? Minus k2 prime e raised to power, if I divide both sides by e raised to power 2x, I'm going to be left with e raised to power x. Yes, if I divide both sides by e raised to power 2x, I'm left with, this will be 3x minus 2x, that is e raised to power x. So I can now substitute this into equation 2. I substitute it into equation 2. k1 prime e raised to power 2x equals to minus k2 prime e raised to power 3x. So we have two of this. We have two of this in this equation. So we are going to be having something like minus 2 into bracket k1 prime e raised to power 2x is equal to minus k2 prime e raised to power 3x plus 3k2 prime e raised to power 3x equals to x squared. So if you are looking at this, we have minus 2 of this plus 3. That means we are left with k2 prime e raised to power 3x equals to x squared. So this is going to show us that k2 prime e raised to power 3x, yeah, k2 prime equals to x squared e minus 3x. Dividing both sides by e raised to power 3x, we are left with k2 prime equals to x squared e raised to power minus 3x. Now this is a derivative, which means you can integrate both sides to get so when we integrate k2 prime, we are left with k2 equals to integral of x squared e minus 3x dx. So we integrate this side to get our k2. So writing it in this, okay. For space, I don't need this. What can I do? Okay, let me write it here. k1 prime equals to minus k2 prime e raised to power x, and k2, okay, yeah. So I can save some space now. Now to integrate this, we are going to use our integration by parts. So we are going to have something like k2 equals to, taking this as our u and this as our dv. So if u equals to x squared, we are going to have x squared. What will our v be? V will be equal to, integrating e raised to power minus 3x, we have e raised to power minus 3x over minus 3 over minus 3. uv minus, I'm using this now, minus e minus 3x over 3 minus integral of v du. This is my v. This minus 3, if I bring it out, it comes into 1 over 3 plus 1 over 3 e minus 3x v du. Du is 2x. If u equals to x squared, du equals to 2x dx. So that's good. 2x dx. So it's also equal to minus x squared e minus 3x. Please, this is just integration by parts. You can watch those videos on it. If you can't follow along. 2 over 3. So if I integrate this one, I have my u as x and my dv as e raised to power minus 3x. So I'm using uv. U is x, v is integral of this, which is e minus 3x over minus 3 minus integral of v du. V is minus 1 over 3, that is from here, e minus 3x. Since u equals to x, that means dv equals to dx. So integrating this, I'll be left with k2 equals to minus x squared e minus 3x over 3 plus 2 over 3 into bracket x e minus 3x over 3 plus 1 over 3 into bracket. Integrating this, I have e minus 3x over minus 3. So I can say minus should turn this to plus, to turn this to minus, sorry. Then I can bring both of them together and say k2 equals to minus x squared e minus 3x over 3 plus, multiplying 2 by 2 over 3, I have 2x e minus 3x over 9 minus 2 times 1 is 2 over 3 times 3 is 9, 2 raised to power 9. Since 9 is already, 3 is here already, you have 27 e minus 3x. Do we need our constant of integration? Yes. Plus c. Plus c. Yes, plus c. So we have gotten our k2. But don't forget this. Our y particular, yp equals to k1. Since this is our what we call k1 e raised to power 2x plus k2 e raised to power 3x. So I'm going to multiply through by e raised to power 3x to get my k2 e raised to power 3x. So k2 e raised to power 3x equals to multiplying through by e raised to power 3x, we just remove only the e raised to power 3x. So I'm be left with minus x squared over 3 plus 2x over 9 minus 2 over 27 plus c e raised to power 3x. So this is my k2 e raised to power 3x. So I'm left with k1 e raised to power 2x. Oh, I was supposed to have left this again. K2 prime. Okay, we have gotten k2 e raised to power 3x as k2 e raised to power 3x equals to minus x squared over 3 plus 2x over 9 minus 2 over 27 plus c e raised to power 3x. Now let's get since k2 prime equals to x squared e raised to power 3 e raised to power minus 3x, k2 prime equals to x squared e raised to power minus 3x from what we have done before, we can now use it into inside k1. So we are going to have k1 prime equals to minus k2. So instead of writing minus k2, we just write it as minus x squared e minus 3x plus e raised to power x, which gives us minus x squared e raised to power minus 2x. So since k1 equals to this, we just integrate both sides of k1 too. So we get k1 equals to minus integral of x squared e raised to power minus 2x dx. So we are going to follow the same procedure to get our k1. I would not like to use the I method. It might not really give you something fine. So integrating this, I have k1 equals to, I can just bring this to the other side to save some space. Minus k1 equals to, integrating this, we have this as our u and this as our uv. So that's x squared. V is going to become something like e minus 2x over minus 2 minus 2 minus uv minus v, the integral of v. V is e raised to power minus 2x over minus 2. That turns this one to 1 plus 1 over 2 du, v du is 2x. So this is 2 and this is x dx. So this cancels out as 1. 2 divided by 2 is 1. So integrating this, we bring this one down and this one will turn to minus k1 equals to x squared e minus 2x over minus 2 plus uv, my u, this is u, this is dv. My u is x, my dv is e minus 2x over minus 2 minus integral of v du. V is e raised to power minus 2x. This turns to 1 over 2 plus 1 over 2 du. Since u equals to x, du equals to dv. Since u equals to x, sorry, du equals to dx. So we are left with k1 equals to this equals to x squared e minus 2x over minus 2 minus x e minus 2x over 2 plus 1 over 2 plus, if I integrate this, I'm going to be left with e raised to power minus 2x over minus 2. So I can join it together with this. This minus turns this one to minus, and 1 over 2 turns this one to 4. So it means my minus k1, I can multiply through by minus now and get k1 equals to, this turns to plus x squared e raised to power minus 2x over 2. This turns to plus x e minus 2x over 2. Then this turns to plus as well, plus e minus 2x over 4. Okay, plus c. I don't really think we need the constant of integration. We are going to see as time goes on. So for this one, we are multiplying through by e raised to power 2x, which means k1 e raised to power 2x equals to multiplying through by 2x is going to remove all our e minus 2x's. So we have s squared over 2 plus x over 2 plus 1 over 4 plus c e raised to power 2x. Okay, plus c e raised to power 2x. So what are we going to do next now? Now don't forget our y particular is k1 e raised to power 2x plus k2 e raised to power 3x. We have our k2 e raised to power 3x and we have our k1 e raised to power 3x now, which means our y particular equals to everything here, which is x squared over 2 plus x over 2 plus 1 over 4 plus, okay, this, since this is already in our complementary solution and this is already in our complementary solution, we don't need it. We don't need our constant of integration for this one. Okay, plus 1 over 4 plus, since this is minus, it's going to be there, minus x squared over 3 plus 2x over 9 minus 2 over 27. Now let's collect right terms and work them out. So we are going to have something like x squared into brackets 1 over 2 minus 1 over 3 plus x into brackets 1 over 2 plus 2 over 9 plus 1 over 4 minus 2 over 27. Now let's work this. We have over 6. 3 minus 2 is 1. 3 minus 2 is 1. So we have 1 over 6x squared plus 18. 9 plus 2 is 11. 11 over 18x plus 27 times 4 is 108. 108. 27 minus 2 is, yes. 27 minus 2 is 25. 25 over 108. So this will be our y particular. I'm going to complete the exam. Yeah. K1 equals to minus K2. There was a mistake here. This is supposed to be minus and plus 2 over 7. This is supposed to be minus as well. This is supposed to be minus. So correcting this, we are going to have something like x squared plus x over 2. Oh, yes, plus x squared over 3. So this is supposed to be minus 2x over 9 minus 2 over 17. Yes, so this is going to be minus instead of plus. So what we are going to be working with now is 9 minus 4, which is 5 over 18, plus this is 27 minus, 4 times 2 is 8. 27 minus 8. 27 minus 8 will yield 19 over 108. So this is going to be our yp. So our y particular equals to this equation. So don't forget our y equals to yc plus yp, which means it is equal to c1 e raised to power 2x plus c2 e raised to power 3x plus all of this plus x squared over 6 plus 5x over 18 plus 19 over 108. And this brings us to the end of the solution for question number 1 using variation of parameters. And that's all for question number 1. Going to question number 2. Going to question